Hello, everyone. Welcome to the second book club meeting for the AI engineering book. So in this week, we're going to talk about the chapter 2 on understanding the foundation models. And I have prepared a presentation of around 20 minutes on the high-level concepts and which I believe the most important things that we need to take away from that chapter. Feel free to raise your hands and interrupt me if you have other questions, because we want to have this meeting in a very collaborative and engaged manner. Let me share my screen. Okay, sharing my screen now. Can everyone see my screen? I cannot see any other faces. So yeah, let me know if you cannot. So on a high level, this chapter is around the core design decisions when building a foundation model, so that as readers and practitioners, we can determine what models to use and how to use them efficiently. So this chapter is not around the technical model training or the mathematical details of the transformer models. Because if you are interested in more the theory and mathematical details, there are a lot of other good materials and resources. But this book is more on the engineering aspect. So understanding these design decisions will help us better understand the scope and what the landscape of the model development right now, and also become more aware of the different settings and differences around these models. To start with, we know training data is super important because that will largely affect the model's performance. And in the past, we only talk about big data, but by talking about big, we are only talking about the quantity and the size of data. However, in terms of the AI model, we also need to care a lot about the quality and diversity of the training data. So maybe some examples will be on the quality, is that we want to have the model to learn a lot of the facts about certain events and things around the world. But there are a lot of fake news and inaccurate information online. And if we feed a lot of this into the model, then the model might not think that is the true answer and give the inaccurate answers as well. Diversity is around many aspects, for example, language or area or certain topics, because we want to build a foundation model which can be capable of performing multiple tasks. So we don't want the model to just be trained on certain training data, maybe on certain political party or maybe certain race or gender, but we want it to have more diversity of the training data source. However, even though right now these popular models are trained on the largest possible amount of available data online, but the limitation is that it will not perform very well on the specific task. For example, if you want to have the model to understand something, information that only available in your internal company or documentation, then that would not be helpful. So the solution usually would be to curate the training data to develop models for a task. So the example covered by the book is on the low resources languages. And also on OpenAI's website, they have a customer highlight essentially on some rural, say, Africa country. Then the government will develop a model based on their own language, which is really very low resources on the internet, but also very important for the local community. So having that kind of model will also increase the government efficiencies when to provide better services for their citizens. And some other popular applications were around the solving the specific domain challenges. So I think these are also where right now most of the startup or the AI project opportunities lies at. For example, in healthcare, law, company internal wiki, and insurance. So usually these data are sensitive. So OpenAI or Google will not able to access that for free in order to train their data. However, these also have tons of the documentation and the information, which could be super helpful if we have the model capable of doing things like question and answering system within this documentation, or do the summary generation, etc. And right now, the most common techniques for fine-tuning or making the model more specific to a task are two. So one is the fine-tuning, another is the RAG. Does anyone have a question? Let me stop here. Okay, go next. So the next part, we talk about the model development. And usually there are two major steps. One is the architect, another is the training. So in the traditional machine learning development, I think the focus is more on training, from local computer training to maybe using CPU or GPU. But the focus on this chapter in the book is more on the architect instead of the training, because to be honest, the book mentioned as well, lots of the gritty detail training is too technical and also proprietary knowledge to these model providers, because usually they will require tons of the computing resources, and usually, like as a practitioners, we usually don't need to learn all this information. And in terms of the architect, so we know right now the most popular model are built on the transformer model, which was developed in 2017. But to better understand why transformer model takes over, we also need to understand the pre-transformer time. The sequence-to-sequence model is the dominant for a lot of the tasks, especially in machine translation and summarization. So that time, Google used the sequence-to-sequence to improve their Google translation system. But it is not perfect, because the problem for that architect sequence-to-sequence is that it only uses the final hidden state of the input to generate the output. So as you can see, it is very slow for the long sequences, and generation are usually done sequentially. Usually will not have a lot of the information on the purest tokens. So that's why transformer with the attention mechanism becomes popular and solve the purest problem, because the attention would allow the model to weigh the importance of different input tokens when generating each output token. So there's a good visualization of this architect in the book. So essentially it helps overcome a lot of other problems, and also gives you actually the response that is not only fast, but also actually answer the question you ask the system because it has a longer context window. However, they also, it's not, even though it has been around and popular for almost 8 years now, but it's not perfect, right? It has many limitations such as high computing costs because we know these companies need to buy a lot of the GPU from NVIDIA, which is very costly, and also the context limitations, which every new model version will say has a longer context window, and as well as lack of real-time learning, etc. So the book also lists some other challenges, new frameworks to the transformer, which is will be, if you're interested, you can check out these ones as well to see whether it's actually better or has any potential to take over the transformer architect. So next, when we talk about the scale of a model, because in the system design, we always talk about a system should be scalable. So similar to a foundation model as well. So there are 3 key numbers listed in the book in terms of measuring the scale of a model. So the first being number of parameters. So we always heard of this model has like certain billions of the parameters. Second is the number of training tokens used into training. The third is flops, which is floating point operations per second, which is really around the computing power by the processors that they use to train the model. And also, as these companies, they train the model, they need to know how much compute is needed. So 2 major factors. One is the model size, like number of parameters. Another is the data size. So in some ways, it's very similar to the traditional like supervised machine learning world, but at a much larger scale. And there's also a thing called scaling law, which will help determine the optimal number of parameters and number of tokens given a compute budget. So this is a common problem, like in the or constraint in machine learning training or other engineering world as well, because maybe we can get a better or more optimal performance and results when given more computing power, but it's not going linearly. For example, when we add 20% more computing power after a certain amount, the performance we get probably will be much lower than that. So in that case, we need to evaluate using the scaling law and other data points to determine which is the optimal budget and computing resources we need. Yeah, let me do a stop here. Just checking if anyone has any questions here. Yeah. Next is post-training, and really this is around how to align the model's output to what the users will prefer to see. Because the problem is that the model will really produce outputs that don't align with what users want due to low quality training data and self-supervision. And the book gives a very clear definition of differences of pre-training and post-training. So pre-training is, it will really optimize the token level quality to predict the next token accurately. So that's what this model and the transform architect really try to do. However, the post-training is that we optimize the model to generate the responses that users prefer to see, because we don't want just to get the answer from the model on the next tokens, but we want to have a more holistic answer, an answer that actually be helpful. So really there are 2 steps or techniques. So the first is called supervised fine-tuning. which is around show the examples of appropriate responses to encourage the model to return the expected responses. This is really just teaching, teaching a kid on certain tasks. We give them some examples so that they know what are good and what are bad. And another example is the preferences fine-tuning. So it's similar idea, but we would define a reward score. So the optimize the model to generate the responses that maximize the reward score. So you may have a question like how we know about the score, right? So that's where the AI labeling come into the page, because we know in the AI, not only companies need engineers, scientists to build and use the model, but also there are lots of new jobs and demand for the data labelers. So that's part of that. So it will basically show the labelers on the model responses, and they will basically score and compare different responses so that these scores and feedback from the labelers can be used to further do the post-training for the model. Does anyone have questions? I hope it all makes sense. Yeah, next we have sampling. So sampling is around the process by which a model generates an output token. And sampling is really what makes the AI model probabilistic. So I think the most important concept takeaway from this chapter is that AI model is probabilistic. That's why we need all the engineering and techniques, all these frameworks around that. And I'm sure you have also heard of a term called temperature. So technically, a temperature is really just a constant applied to the logits before passing into the softmax transformation. And you are, like say, when you are calling the OpenAI API, you can also set the temperature number. So a higher temperature, like constant, will reduce the probability of common tokens. And in return, it will increase the probability of the real token. And in that way, we will encourage the model to give more creative responses. So basically, if you want the model to be more creative on the answer, you will give a higher temperature. But if you want more expected, maybe a boring response, maybe lower temperature. So yeah, so basically the model being probabilistic, it is helpful for creative tasks or brainstorm ideas. For example, in many cases, I want to come up with certain name for a project or for a team, and usually the AI can give you a lot of the ideas, so it's really good for that. However, there are two really big challenges right now, mostly because the AI models are probabilistic. So one is inconsistency. So in the following chapters, chapter 5 will talk more on. So basically, the information I listed here are more the current techniques to get around with that, but it's not like the perfect solution right now. So one is crafted prompts, basically give better prompts to let the model have more consistent answer. And another is having a memory system. For example, if we use the AI to grade a student's essay, and it will give different scores on different API calls. So one way to get around with that is to store the score from the first response into a database or in a cache, so that when it runs again, it will basically retrieve that previous answer instead of giving a different output on the exact same input. And another point is the hallucination, which is also a very popular term right now, like in social media. So several techniques to overcome that also use better prompting and context construction techniques. So really to better use that, we need to come up with a better prompts. And another one is a term called RLHF, is reinforced learning from human feedback. So essentially, you as a human, you give the model some feedback so that the model can know what is right and what is not, especially if the original answer is off track, totally like hallucinating and totally off the track. And then if we have give that some feedback, hopefully it will get the answer right on the track and get towards the helpful information. And the next very important session is on structured output. And personally, I really learned a lot from this one because these are really a lot of the challenges I like also come across and try to solve in the past projects. So this is really about around when you are calling the API from foundational model, the output is really not structured, right? Even though you put in the prompt, they give me the return as an integer or just a certain string, certain date, but there's no 100% guarantee that it will always give you that. So, I think the recent development, like from 2 years ago now, is that OpenAI's API, you can define the JSON as the output format, which is really a great news for developers to integrate into the production system. But for a lot of the other models, there's still nothing like that. So there are now a lot of possible ways to overcome that, to have that more structured output. So one is prompting. So basically you have one prompt or API call to get the result. Let's say we have a document and we want to extract all the, let's say, name. So because the names are more difficult to extract. Unlike numbers and dates, maybe you can just use in Python to pass the documentation. But if we want to pass all the public figure names from document, and then we can have another prompt to basically validate the output from the first prompt to see whether the output is actually just name only instead of anything else. So this is one way, but it will add the extra cost and latency. So the second way is the post-processing. So essentially the script to fix the common mistake. Let's say you want to extract the numbers, but always the number extracted have some other things like a string or something, but you have one the integer or other data type, you can have some other processing to do that. So the third one is the constraint sampling. So this is to guide the text generation towards certain constraints. So this is also a common prompt technique, is that you tell the model that the answer should be in these ABC options. And now there are also other frameworks to help you around that, to guide the model to constrain the answers. Lastly, the book talk about fine tuning. So essentially, it's to add another layer on top of the model. For example, you want to have a classifier model, and then you basically build a system so that the output and the examples for that model will be following the desirable format. So yeah, this is the final slide here. So what are the key takeaways from this chapter and the needed information you need to know before we read the following chapters? So I think the most important thing is that really want to build the system and workflow to harness and mitigate AI models' probabilistic nature. So by harnessing, I think really this means that we want to take advantage of the AI model because it really gives a lot of the simplicity and opportunities that we don't need to build a traditional machine learning from scratch for certain tasks. Instead of it can do a lot of the tasks easily without doing a lot of the training ahead of the time. But also very important is to mitigate the probabilistic nature, because maybe we cannot build 100% deterministic model, but at least we want to have the outputs very systematic, especially we want to build that into the production system. And followingly, it's very important to evaluate the response, whether it is actually the consistent and not hallucinated result, and also following the structured, desirable format. Because we don't want to have the model to have unexpected changes in terms of the format or the expected answers. So that will be the focus in the next two chapters on AI model evaluation. And so that's about the summary for this chapter. Let me return back to the meeting here. Okay, yeah, so hope my short summary is clear, but definitely if you want more details around that, I highly encourage to read this chapter, as well as references that Chip included in the footnote. And now we have some time for the Q&A. So does anyone have some questions to discuss? If not, I can start with some questions.
I had some questions on how, I did read a bit about not the book, but general reading on how temperature works. But I think it'll be nice to discuss. I thought temperature.
So let me rephrase your question. So are you saying about the model architect? More details around that?
So you mentioned about temperature, right? Like where higher temperature means rare works get prioritized, etc. So just curious, from at the end of the model, we have a softmax of all the tokens, and we sample from the softmax. We get a sample distribution. I mean, that softmax is technically considered sample distribution. I mean, a distribution, and we get a set of tokens. But how does temperature affect these?
How does temperature change that, right?
Yeah, just curious. I just wanted to learn a bit more.
Oh yeah. So so if you have the book, so they have some details going into that, but yeah, maybe it will take longer time for me to explain. But on a high level, essentially, it's a constant. You have this logic distribution, and you divide that constant, and then basically doing the probabilistic distribution again. So this way, it's like applying the logic that the larger number and with the smallest number don't appear to be really that far away. Because otherwise, the real numbers a really like small probability will never be chosen by applying like that temperature. So essentially, it makes the probabilities of these words closer. Hopefully that makes sense. But yeah, I can find some maybe better YouTube materials of thing and share in the Discord channel later on.
Yeah.
But essentially, once you see the mathematical formula of that, it will be super clear.
Yeah, makes sense. I just came across the blog right now. I could share it with you.
Sure. Yeah, I think among these sessions, the one I find really relevant and valuable for me is. Okay, thank you. Yep. So the getting the consistent output and also the structure of format. So yeah, I'm curious whether any of you have tried to solve the similar challenges before. So because on the inconsistency part, right? Because really, if we are talking about the AI into the production, we want the response to be consistent. If we want to have some, well, if we just want to do a summary on the reviews, I think that use case is pretty straightforward. However, if we want to have some sort of extraction using AI, let's say we want to extract certain number, dates, names from that, we just want the answer to be that object or the certain format. So we want that even if we have some other Python script to do that, but it's also more like a advantage applying to that. It does not guarantee we will capture all the possible formats that we get from the model. Yeah, another thing is that I previously used basically try to use the random model into my side project, essentially to evaluate a user's answer on certain say, technical like interview questions, right? And really a challenge is the first time it will get maybe 7 out of 10, but then the next time the user clicks that, maybe it's 7 out of 10. So that is something really, from the model perspective, very interesting, but from the developer engineering perspective, very challenging and difficult. Because then if really the system or the product relies on that score or information from the AI, the model response, then from the user perspective, how can they build the trust into that product? Because they won't care about whether you are using Gemini or the OpenAI model. They only care about whether we can trust the result of that response. Yeah, so because I think that time I also basically tried to use a similar technique, essentially have a memory system, essentially the first round to store in the database so that we won't have the inconsistent result when trying to run the same API call again. Yeah, I think speaking of that, another interesting thing or learning I see here is really maybe sometimes we are in some way overusing the model to do certain tasks. Especially we want the structured format. So the examples here is that if we want to extract certain or do the summary thing, then we only need to use the foundation model. But say we want to just extract certain dates or number. In that case, maybe just using the regex pattern in a simple Python script would be sufficient instead of having a prompt to do that. Yeah, because I faced a challenge before when I want to pass a long document to extract the questions and answers from that. But in that case, the model might not be the best. But combining the traditional regex pattern and some API calls, which I found is pretty sufficient and good to use. Yeah, anyone else want to share? So, so maybe another question I have for the group is that beyond from these topics mentioned, like temperature, fine tuning, what some other topics that you see a lot or you are interested to learn more about? So that in the future, maybe we can focus more on that and talk more on these topics.
When you say topics, are you suggesting like topics of the book, or basically topics in the book?
No, not only the topics of book. I think generally, like the temperature, for example. I think that's a good example. Because the book is more the chapters is more on a structured framework on the common topics that we need to learn. But maybe there are some other, new topics or topics that are not very covered not much in the book.
Mm-hmm. Makes sense.
Mm-hmm.
I'm actually a lot interested in the agentic, uh, architectures. That's in uh, because what I see is not there isn't a lot of theory on how to productionize agents. A lot of people are suggesting a lot of stuff. For example, you might have seen what Anthropic might have published. I also came across what Chip had published,
Mm-hmm.
and there are a few, I would say, articles, but not that great. Apart from the two that I mentioned, then I've seen the Magentic one from Microsoft and meta prompting paper from OpenAI. All these talking about different techniques. So I'm just curious how people, like if anyone has came across any specific stable architectures that would help multi-agent, orchestration, for instance. If someone has worked on them, that'd be great to know.
Mm. Yeah, I agree. Agent is definitely the hottest topic right now. Yeah, I think that's one thing maybe we can do is that that week maybe we can have another 1 week or two to see if we have any volunteers or in the Discord channel who have more experience in AI agent and do some more dive deep knowledge sharing or things around that. Yeah, like so that we can go beyond the information in the book and dive deeper into that. Or if anyone has done any interesting side projects with AI agents, maybe that's also a good channel to share so that we can see how it is, how it looks like in the system.
Any preferred frameworks for anyone? Like
You mean for
framework?
agent or in general?
Excuse me, you're not audible. It sort of cut off to me.
Oh, so you're asking the framework for the agent specifically or in general?
Yeah, agents
Mm.
specifically. I've worked with semantic kernel. I've tried something on the older version of Autogen, not the new one. Probably Autogen is now too. Like there's Microsoft Autogen and there's independent Autogen. So I haven't worked with the either. I mean, either of the new ones.
Mhm.
Also tried building agents with OpenAI APIs. I mean, no, when I say like native SDK for OpenAI.
Got it. Mhm.
But I'm still curious how, like, if there are any other, like, I've heard of Crew AI, but I haven't tried any. I also have Haystack. I'm not sure how good they are for agents right now. I've tried Haystack for RAG, but uh, cannot think of anything else that I might have come across in terms of agents. But probably, oh yeah, LangGraph is something that I haven't tried. I know there is a lot of people who would prefer LangGraph.
Yeah, that's it. Yeah, and then the land graph is doing something around that. And also like Llama Index, I think they have something.
Oh yeah, no mind. What's the value add in terms of having a framework is something that I'm also very much interested in because I
Yeah.
haven't seen a lot of, I mean, lack of control is something that I dislike. So probably frameworks are, in a way, not giving a lot of control to the developer in terms of controlling an agent, for instance, right? Like,
Mhm.
yeah, also logging becomes tough. Finding traceback and troubleshooting gets tougher. So if there is anything that has made everything possible and easy, I just want to know if someone has tried any of those things.
True. Yeah, I agree with you a bit because I feel right now is like tons of resources on that agent or anything around AI, but it's right now it's actually become harder to actually get started because you have a lot of choices. And once you get on certain framework, and maybe it's like they are more difficult to transition to other ones. And we all really we want to choose the most popular and maybe the best one. That will stay longer. Yeah, because I think really this specific framework or tools are not the focus on this book because as Chip mentioned in the book earlier is that the frameworks and tools come and go, but really the book is more on the fundamental engineering principles that will stay for a very long time. But
Yeah,
we
it makes sense too. Like uh, honestly, frameworks will not stay. I've heard a lot of uh, like I've heard from people from Microsoft who are pushing for probably 3 or 4 frameworks. Like they have Task Weaver for analytics, again
Mhm.
agentic. They have semantic kernel. They have Autogen. So they also had guidance. I don't know if guidance is
Yeah,
long, but I've heard from them first giving like for quadrants of use cases and for different frameworks for all those. And I've also heard the same people say at the end, we think frameworks would not stay test
yeah,
of time and they would all go back to native SDKs.
got it. Yeah. Mm. Yeah, actually, I see similar comments as well. Especially people are concerned around maybe say for simpler tasks, using framework is overkill, and also yeah, some other challenges are maintaining and keeping up dated with the framework. Because what I see is that maybe sometimes if within the company have enough talents or good use cases, maybe within the company they can build their own frameworks or libraries essentially to do to more to customize the use case.
Mhm.
Because using the other framework, you still need to customize. But yeah, I think that's really great topic to dive into and maybe share more in the discuss channel because definitely I have that. Well, to be honest, so at, at work I have worked with traditional machine learning and also some like general AI, but I haven't actually seen any of AI agents in production, like for the you know for the work project. So also one thing that's a topic I'm interested about, like because so many hype, but whether like what are some use cases and problems to solve using AI agents for maybe not just the purely AI companies, right? Because for the prompt engineer, like calling the APIs and the ML, there are already a lot of the good use cases to provide value. But for the agents, I think it's yet a unknown field in some ways to see um, how it is like to deploy the agent and whether it differs from the traditional machine learning and AI, and as well as like how, especially from the product perspective, like how it actually provides the value for the users. Yeah, because definitely
So
I
I think
think.
I think
Oh,
I think oh yeah, someone has raised a hand.
oh yeah, Galu would like to.
You're not
Sorry,
audible.
a little bit hard to hear. The volume is a bit low. Mhm. It's difficult to hear you, Galu. So, and maybe you can also put in a comment in text, and I can read out your comment or question as well, if you prefer.
Yeah, while he's typing, so one thing that I've seen in regards to uh, in regards to AI agents, or specifically foundation models as a service from big techs, and they may as well be pushing the idea of AI agents probably
Yeah.
because they get a lot of money in just deploying the models,
Mm-hmm.
and the benefit that other companies may experience is the benefits of democratization, where anyone can use yeah, top models like OpenAI GPT-4 or O1 or O3 or even R1 on cloud as a service.
Mm-hmm.
And because prompt engineering is a thing, people get to use okay, how do you approach it?
Mm-hmm.
Yeah, I think I can talk a bit about it. So, what happens is people get to use these technologies without having to pay a lot of money, and then because all of these models are instruct models, we get to instruct these models in a way we want them to respond. And while come across this article from Rasa's co-founder Alan Nicole, where he says prompt and pray is actually dangerous. But I am not a staunch believer of it because honestly, Scrum does a lot of good work, and I think we just need to like sort of evaluate, and that's where eval-driven development is what people talk about these days, and I think that's key. But again, evaluation is also a tough topic where we may have to invest a lot of time. Should you evaluate a result from let's say I have GPT-4 O model trying to give me an answer. And if I'm to judge the result with a GPT-4 or Mini, the Mini would say it's wrong, but it's right. So
Mhm.
somewhere I cannot be using. I mean, probably I have to enhance evaluation in a different way because spending like honestly, I've used both. So I've seen that GPT-4 is quite costly compared to GPT-4 Mini, and you wouldn't want to like have a judge that does the same job as the composer. Composer needs quite a lot of. So when I say composer, I'm talking about the planner. Some people call it planner
Mhm.
in the agentic systems. So yeah, it's getting better. Honestly, the theory is getting better, and I'm sure it's only because it's democratized. People are so much into this. Like people are talking about AI agents. Everyone. I work for a company here in Canada. I've seen everyone coming across AI agents. Should we have it? Yeah, we should have the like we should have this use case, that use case in AI. And so it's come to a point where people are very hopeful and people are very ambitious about AI agents. And I like it, while I also dislike the idea that if I have to train a model, I cannot because I mean probably I may be able to fine tune a model, but not train a model from scratch.
Yeah.
So that leaves me at a point where big tech's controlling the market, and we're just feeling hopeless about not being able to train a model. So yeah,
Mhm.
and answering Galu, I don't know.
Yeah.
Yeah,
So.
so I've trained. I mean, I've actually built a model. I mean, agent with OpenAI SDK. It's actually extremely easy, and it's so easy to control things. The way, like, it's basically tool calling. So uh, the first call to the OpenAI would give you the list of all the tools. It is even possible to have parallel tool calling, which means it'll give you multiple tools to call. And probably there's a technique where you can also say this tool is dependent on the other one, so that will not be called in the first pass, etc. So all these things are possible. Now, let's say you have a set of tools suggested by the LLM. It's just then what you do is execute these functions or these tools, and then you populate your context with result, and you send it back to the LLM,
Mhm.
and it comes back with further tool calls if required, or it will just send you a response. And you just need to define the tool schema,
Mhm.
and once you have the result, you can actually you know evaluate them with whatever LLMs you have. Or I would love the idea that we should offload the requirement for evaluating to smaller language models. But yeah, I don't know honestly how it's going to be. I've seen certain like there was a time when I enforced that it should always fail. If the evaluator fails a result, I retry it a couple of times, and if it does not come back with the right result, I'll suppress the result, and I'll just send a fail to retrieve a response of response to the user. But I think at a point I thought no, I should not. I just throw the evaluator's score to the logs and just not let the evaluator suppress the answers. Right?
Mm.
It's interesting. I don't know if there is any specified method to. Yeah, there should be a few, but at least I'm lazy to find out.
Definitely. Definitely. I think that's a question we all are very interested to learn more about. And by the way, thanks so much for sharing your experience and knowledge. That'd be super
Mhm.
helpful. And I don't have anything to add because I don't have any experience working with agents yet. But I hope that answers the question, Kadu. Mm. Yeah, I think we're almost at time. So yeah, we finished the recording. Stop recording.